Engineering Mechanics, Ladder Friction. A 4-meter long ladder, 180 Newton in weight, is supported against a wall which is perpendicular to the floor with its foot on the floor. The coefficient of friction between wall and ladder is 0.2 and that between floor and the ladder is 0.4. The ladder supports a weight of 900 Newton at a distance of 1 meter along the ladder from its top. Compute the least value of the angle between floor and the ladder for its equilibrium. This is a 10-mark question. So if you draw the free body diagram, you will get the figure like this. So here ACB, that is a right angle triangle. AB is the ladder. The length of the ladder is 4 meter. The weight of the ladder is 180 Newton and that is acting through the center of gravity or centroid of the ladder, that is point G. So that is half of at a point that is at the midpoint of ladder AB. So AG distance will be 2 meter and GB distance will be 2 meter. If the ladder is not in equilibrium, then it will slip. That means the end B, which is touching the floor, that end will move to the right. So the frictional force will be developed in the opposite direction and that will be towards the left. So FB denotes the force of friction acting at the contact surface between the floor and the ladder at point B. Given the coefficient of friction between wall and ladder is 0.4. The vertical reaction at B, that is RB, therefore force of friction FB equal to mu into RB, that is 0.4 into RB. Let the ladder be inclined at an angle theta with respect to the horizontal. Now, if you analyze the end A, that is the top point of the ladder, you can see that if the ladder is slipping, what will happen? The top portion of the ladder will move downwards. So, frictional force will be developed in the opposite direction, that is frictional force will be acting in the upward direction. So FA, that is the frictional force, FA equal to mu into RA, where RA is the vertical reaction at A. So that will be acting normal to the vertical wall. So RA that is denoted there and FA is equal to mu into RA. Mu, that is coefficient of friction between the wall and the ladder is 0.2. So FA equal to 0.2 into RA. Now it is also given a weight of 900 Newton is acting at point D, that is at a distance of 1 meter from the top point, that is A, along the sloping side. So the distance DB will be, total distance is 4 minus 1, that is 3 meters. Now first we will consider the triangle ACB. It is a right angle triangle. So cos theta will be BC divided by hypotenuse, that is AB. So the distance BC will be equal to AB cos theta. Here AB is 4. So BC equal to 4 cos theta. Now if you consider the same triangle ABC, sin theta will be opposite side by hypotenuse, that is AC divided by 4. So AC will be 4 sin theta. Now if you drop a perpendicular line from D to the floor, that will meet the floor BC at E. So DEB, that is a right angle triangle, right angled at E. If you apply cosine rule, if you take cos theta will be adjacent side by hypotenuse. So adjacent side is BE, hypotenuse is 3. So cos theta will be BE divided by 3, or BE will be equal to 3 cos theta. The weight of the ladder is acting through point G and that is acting vertically downwards. So it is 180 Newton and that is acting vertically downwards. So if you draw a perpendicular line from G to the floor BC, it will meet BC at a point F. And this triangle GFB becomes a right angle triangle, right angled at F. So for this triangle, Cos theta will be BF divided by hypotenuse. Hypotenuse is 2 meter, that is BG. So BF will be 2 cos theta. So all these distances AC, BC, EB and FB, all these 4 distances we have to calculate in order to find out moment about point B. Okay. Now the question is, you have to find out the angle theta between the ladder and the horizontal, that is the floor. In order to find that, we imagine that the ladder is in equilibrium, so it will obey the conditions of equilibrium. So algebraic sum of the forces along the horizontal will be 0. Therefore you will get the equation RA is equal to FB, that is RA is equal to 0.4 into RB. Similarly, algebraic sum of the forces along the vertical is equal to 0. So FA plus RB is equal to 900 plus 180. So FA is 0.2 into RA. So rewriting, you will get 0.2 into RA plus RB is equal to 900 plus 180. So solving these two, you will be able to get the value of RA and RB. Now the third condition of static equilibrium, that is algebraic sum of the moments about any point is equal to 0. So taking moment about B, the first force is FA. So that FA is acting at a distance of BC from B. And if you hold your thumb, that is thumb of your right hand at B, and turn your forefinger along the direction of the arrow of force FA, you can see that your forefinger will be rotating like the needle, or like the needle of a clock, like that. So that means what? It is moving in the clockwise direction. So clockwise means that is a clockwise moment. So clockwise moments we will give it the notation or the sign positive, and for anti-clockwise we will give the sign negative. So the moment of force FA about B will be FA into BC. So that is 0.2 RA into BC. Now next force is RA. So that is acting at a distance of AC distance from B. So the perpendicular distance between the force and the line of action of the force and the point B, that is AC. So RA into AC. Here also, if you hold your thumb of the right hand at B and turn your forefinger along the direction of the arrow of force RA, you can see that it is also a clockwise moment. So that is also positive. So plus RA into AC. So AC is the perpendicular distance between the line of action of force RA and the point B. Now next force is 900 Newton. It is acting downwards. So if you keep your forefinger, thumb of your right hand at B, and if you rotate your forefinger along the arrow, along the direction pointed by the arrow of 900 Newton, you can see that that will be in the anti-clockwise direction. So you can give it the sign negative. Similarly, 180 Newton also will cause an anti-clockwise moment. So 900 minus 900 into BE and minus 180 into BF. So the equation will be 0.2 RA into 4 cos theta plus 4 sin theta into RA equal to 900 into 3 cos theta plus 180 into 2 cos theta. So here I have written alpha, but the actual angle marked in the figure is theta. So you can consider it as theta itself. Now you will get this equation if you take the moments. So all of you write the equation on your own. Do not copy this. Just try to write down the equation on your own and then verify whether you are getting this equation. Okay. Now after getting this, since there is cos theta, sin theta, etc. in this equation, it is easy to just divide throughout this equation by cos theta. So you will get an equation 4 RA into tan theta plus 0.2 into 4 into RA equal to 900 into 3 plus 180 into 2. So if you solve this equation, you can obtain the value of theta. So theta will be tan inverse of 1.7 something you will get, and if you solve the value, okay, you will get the value of theta as nearly 59 degree 43 minutes 3.24 seconds. Second question, a ladder AB 3 meter in length and weighing 180 Newton is placed against a wall with A at the floor level and B on the wall. The ladder is inclined at an angle 60 degree with the floor. The coefficient of friction between wall and ladder is 0.25 and that between floor and the ladder is 0.35. In addition to the self weight of the ladder, it has to support a man weighing 900 Newton at the top. B. To prevent slipping, a force is applied horizontally at the level of the floor. Find the minimum horizontal force in this condition. So here, this is very similar to the previous question, but here they have given the angle theta as 60 degree and the man is standing at the top, that is at B. A weight of 900 Newton is acting vertically downwards. Another thing is, you are asked to find out what push or what amount of force, horizontal force, is required at the end A, that is at the point where the ladder touches the floor. So at that point you have to give a push, then only the ladder will remain in equilibrium. So when a person is standing at the top point of the ladder, you have to apply a push at the bottom end where the ladder touches the floor, and then you have to measure the amount of, you have to calculate the amount of force required at point A, horizontal force required at point A. So how will you do this? Very simple. You have to apply the conditions of equilibrium. Then here the first equation, algebraic sum of the forces along the horizontal equal to 0. So RB equal to FA plus F. Okay, so FA is 0.35 into RA and FB is 0.25 into RB. Now vertical forces is, if you consider the algebraic sum of the vertical forces along the algebraic sum of forces along the vertical direction is 0, then you will get FB acting upwards, then RA acting upwards, then 900 Newton and 180 acting downwards. So FB plus RA equal to 900 plus 180. So that is 0.25 RB plus RA equal to 900 plus 180. Now taking moment about point A, you get FB into, what is the distance? AC. FB into AC plus RB into BC minus 900 into AC minus 180 into AD equal to 0. From triangle BCA or ABC, you can find out the values of BC and CA. So cos theta will be CA by 3. So CA will be 3 cos theta and CB will be 3 sin theta. Similarly, from triangle GDA, you can calculate the value of AD. So GDA is a right angle triangle. So G is the midpoint of the ladder, that is the distance AG will be 3 by 2, that is 1.5. So cos theta will be AD divided by 1.5 or AD equal to 1.5 cos theta, cos 60. Okay. So you can find the values of BC, AC and also AD and apply, and you will get these equations. So RA plus 0.25 RB equal to 900 plus 180, RB equal to 0.35 into RA plus F